Okay, this presentation is about managing Socket Direct OCP NIC 3.0. I'm Yuval Itkin, Distinguished Architect from Mellanox Technologies.
And my name is Patrick Scholler, a Master Technologist with Hewlett-Packard Enterprise. I'm a hands-on embedded management architect with focus on secure management of option adapters.
OCP NIC 3.0 introduced support for multi-socket servers, which means that each CPU socket may be connected independently to a different network controller. At the same time, it does allow also for multiple CPU sockets to be connected to the same network controller in multi-route connection. Mellanox introduced Socket Direct technology, which solves the multi-route aspects as illustrated below in the table taken directly from the OCP NIC 3.0 spec that shows the exact encoding of multi-sockets which support 2 or even 4 sockets to connect to a single network controller device. Socket Direct is here to solve an issue for concurrent connection of single network controller to multiple CPU sockets, because you can gain from the improved performance by saving the penalties associated with extra latency and power due to the QPI or UPI interconnection between the sockets, and still let each and every CPU within its socket to directly connect to the network controller. So by that you gain performance from one side, you gain power saving on the other side, and you do not lose on your total throughput. Managing Socket Direct is something that requires some special attention. First is when you connect in multiple independent connections over PCIe, it's hard to do the right inventory reporting and identifying the multiple connections as belonging to the same device. BMC interface is yet another aspect on how to connect such device which concurrently connect to multiple sockets to the BMC, as well as the pre-OS aspects like combining the reflection of all these attributes into one coherent set of menus. Combining all these new capabilities of Mellanox Socket Direct technology with compatible servers like OCP NIC 3.0 compatible servers can address all these goals.
From the management controller view, we need to have the ability to sort of inventory the optional adapters that are plugged in, such as on an OCP 3.0 server. Out-of-band management has 4 sort of fundamental functions. You have discovery, inventory, monitoring, and action. Discovery is typically going out there and just discovering that something's inserted. OCP 3.0 NIC has physical present pins, makes it simple. Inventory is being able to say what is inserted. And that again is done using the OCP 3.0 NIC specification, leveraging the EEPROM with the inventory information, as well as core PMCI working group specifications. Monitoring, again, is done through PMCI to be able to check for temperature, power, events, alerts, things like that. And then if an event takes place, some call to action. One of the tricks, of course, is going to be able to identify having 2 CPUs pointing to the same network controller, as we showed in the previous example. For the most part, management controllers today understand PCI topology in a way that's native to the platform. It does appear to be more vendor unique, and typically the MC and the BIOS will have an early communication protocol to share PCIe topology as well as sort of user visible location, such as PCIe slot 1 or OCP 3.0 NIC slot, etc., something like that. Some of this information is also populated in the DMTF industry standard SM BIOS records, such as Type 9. Next.
Now, BMC using MCTP over PCIe VDMs needs to identify a single device, even when such device has multiple PCIe connections. Therefore, this means that you have to expose a single device to that BMC.
And of course, the DMTF, the PMCI working group, has industry standard specification that allows the MC to identify a device, say, that may even have multiple management endpoints, which too could be MCTP, PCIe, VDM, or you could even have a mix of, say, SM bus or a PCIe VDM, those being the physical interfaces. The MC gets the visibility into the PCI parameters, again, typically through that pre-boot BIOS to BMC communication protocol, where the topology and the PCI configuration space is transferred.
Now, pre-OS implication is tricky when talking about Socket Direct use case. From one side, you want to have coherent menus allowing you full controllability and observability and consistency of all the parameters. You want to see the same settings for the NIC ports, regardless if you are looking through one or the other socket. You need to have one set of menus, and you need to be able to see all the parameters. Therefore, you require to configure even the boot parameters, but not confuse the system boot between the two connections. So the system will properly be configured to boot through the socket that actually is being used for pre-boot environment, and you need to be able to configure all these different parameters in a simple and non-confusing manner. Therefore, reporting unified pre-OS boot menus really mandates to reflect all these information parameters in single coherent set of menus. Now, Socket Direct NIC really allows to get exactly that consistent boot configuration parameters on one set of menus, regardless of the PCIe buses enumeration sequence. So if you enumerate the first bus before the other, or the other before the first one, it doesn't matter. You'll always see the exact same look and feel, the exact same set of menus, and the exact same association of these menus to the right interface and the device ports.
So this slide provides a view that an OCP 3.0 NIC compatible management controller could display. You'll notice that the list is sorted by port over on the left, and by looking at the PCIe addresses, you can see that we have a dual function device, function 0 is function 1. Things to highlight on here is that each port shares the same bus on each processor. So for example, port 1 on processor 1 is all coming off of bus B6, B6 being hex under the PCI address. Each port is the same device, but it has a different function. You could also have two devices in a different enumeration. What's important here is that you can see that both ports are available to both of the processors. Looking on the far right, you'll see where the processor count is. And on our next slide, we have a visual display of this. Okay, so on our right, we have our example of our CPU 0 and CPU 1, both targeting the same OCP 3.0 Socket Direct adapter. Next. And so you can see from CPU 0, we're going to have both of ports 1 and 2 are both visible from CPU 0. And then next. And then you can see that ports 1 and 2 are also visible by CPU 1. And so both CPUs have visibilities to both of the ports in this example, and then through software management can now be load balanced. And this, of course, is important because from an out-of-band management, connections with Redfish and other data center management tools, you're going to want to be able to report this up, especially for connecting to switches and things. Next.
So here we see the option ROM menus. At the top level, we see a single entity. It's the NIC, and you have already at the top level menu indication that that NIC has two interfaces. You may want to configure each of those interfaces independently through the same menu set. So the IT person going to configure that machine will not have to think about configuring the boot on one interface or over the other interface, because all these menus are unified into one menu set. So by choosing either one of these, the user can configure all the parameters associated with the device as being reflected on the associated interface. So when we go from the top level and go into the actual submenus of each of those two interfaces, you can see that you can get the PCIe device ID on these two buses. You can see the PCIe address being unique on all these different interfaces, and you can see that also on each and every interface the device has its own unique MAC address as reflected in the previous slides, because that given port is reported with different MAC address for each and every socket, so you can uniquely direct the traffic to the right socket as connected to the NIC. So there is exact and very accurate mapping which is fully visible to the user. Of course, the user can configure virtual MAC addresses for each one of those. So these cards are available. This is not kind of forward-looking. You can see that both ConnectX-6DX devices are already available in ConnectX-3 in OCP NIC 3.0 form factor, as well as ConnectX-5 devices. You can see below you have links for where can you get additional information regarding those devices and Socket Direct technology. Definitely, it's important to complement multi-socket platforms by complementing that in SMBIOS representation. Once NCSI revision 1.2 is released, please note that you can leverage the added functionality, which definitely is applicable even for Socket Direct use cases. Please bear in mind that when you're implementing Socket Direct platform, you shall follow the definitions, some of which were quoted in this presentation, is outlined both in OCP NIC 3.0 spec, as well as the accompanying pinout table and bifurcation decoding table, which is also available at the provided link. Thank you very much.
Thank you very much for attending our presentation.
If you have any questions, we are here to answer.
We have a couple.
Sure.
Do you want? I previously answered the one about the difference between Socket Direct and multi-host in the chat, where I said Socket Direct is two processors, same host with two physical paths to the same network device in this case, And then multi-host would be two independent, like compute nodes, two independent hosts sharing the same NIC. Do you want to expand on that? I see.
Yes.
Deepa.
The difference between multi-host, where you have two independent hosts running their own independent power domains and operating systems, and Socket Direct use case, where you have one system like a NUMA node, system requires different settings, like it only boots once and you have to configure the boot menu once for each and every server, even if it has multiple sockets. While when you operate in multi-host, you need to allow, for example, to configure the boot info for each and every host on its own. So there are inherent differences between multi-host and Socket Direct. Any further questions?
Did you answer the permanent MAC address? I wasn't sure.
Each and every port is reflected using a unique MAC address for each and every bus. So the traffic that goes to a particular socket is uniquely identified.
Right. And I think as we present, it's the whole balance of being able to push more throughput by shoving it down two physical lanes.
Any further questions? If no, then we thank you all for being.
There's one. Yeah, there was one about how many sockets. 2 max or 4.
Yeah, we can support up to 4 sockets natively.
Yeah, I think we could do 4. Yep. That's a big box. Big box. Yep.
Okay. Thank you all for being on this call.